Today we have discussed about this max mode of 8086 processor. So just a quick overview of that, and then we'll cover this last topic of the maximum mode, that is the timing diagram. As you can see the diagram on your screen. Okay. So Muskan, what about the Indian authors, sir? Muskan, see there are books which were written by the Indian authors. So you can also refer to them. I don't know any specific Indian author, but there are good books which are from there. I mean, from the Indian author. But Barry B. Bray is a good book because it is the straightforward book from the Intel series. Okay, so it is a dedicated book from the Intel. So that's why it's the very good book. Otherwise, you can also refer the book that is Lou Gibson. I'm writing the name, Lou and Gibson. That is also a very good book. And the last, you can refer to BRAM. So Lou Gibson and BRAM, you can also refer to these books. Okay, so there are Indian author books, but I'm not sure which Indian author book is good because I haven't read any Indian author book on 8086 processor. But anyhow, you can refer to these books and don't bother about this difficulty in the language. So if you want to study good book, language is also a barrier. So don't just cross that barrier. Don't avoid yourself for studying a good book just because of a language barrier. So you start study, एक बार पढ़ो, दो बार पढ़ो, तीन बार पढ़ो, चौथी बार, तीसरी बार समझ आनी शुरू हो जाएगी. First attempt में हो सकता ना समझ आए, but you start reading that book first attempt, second attempt, surely you will get something in the third attempt. Okay. So anyhow, so we were discussing that 8086 in the max mode. So we have studied all these things which you can see right now on the screen. So the last topic for the day is the timing diagram of 8086 processor in max mode. As I told you earlier, also there can be timing diagrams with respect to the control signals. And what are the control signals? So control signals are memory read, memory write, input read, and input write. Okay, so yesterday we have seen that how we have extracted these control signals, not from this processor only, from the other processors also. I told you about that you can connect 8087 processor with this and 8089 processor with this 8086 processor to enhance the strength of the complete system. So 8087 is a dedicated processor for the complex mathematical operations or computations. 8089 is for increasing the inputs, IOs, inputs and outputs in the system. So we can connect 8086 and with 8087 and 8089 for these kinds of operations. Okay. So now moving further, so yesterday we have discussed all these things in detail. So just what you say, that just the timing operation or timing diagram of that with respect to your 8086 maximum mode. Okay. So do you want to ask anything up till now? Any doubts up till now in the maximum mode? Okay, so anyhow, just have a quick look on the pin diagram because again, this is going to play a vital role in timing diagram. So hello, yes, please.
Good morning, sir. Sir, please give a brief mode of maximum mode. एक बार sir brief कर देंगे, please, sir.
Okay, so just a quick recap of all the things which we have discussed yesterday in the maximum mode. So we have discussed 8086 in detail, and we have seen when we were. I hope the pin diagram screen is visible to you people. Yes, sir. Okay. So we have discussed the minimum mode, we have discussed the pin description, but we haven't discussed these pins. I mean from pin number 24 to 31. So these pins are dedicated pins in maximum mode. The purpose of maximum mode, was to enhance the strength, was to enhance the capability of the process system. So you can connect more processors in the system. So I gave you one example yesterday. So this was the birth of networking. Like अब जो आज की डेट में YouTube या Facebook whatever softwares या जो networking के tools अगर आप applications देख रहे हो, so from where it started from this thing that when someone thought of connecting two processors together. Earlier, someone thought of connecting two processors together, then someone thought of connecting two computers, then multiple computers, and then the networking on the cloud and all those things means utilizing or sharing the resources. So, if a 8086 processor, when it is connected with other processors like 8087, so why we connected 8086 with 8087? I told you that 8087 is a dedicated chip which was able to perform the complex mathematical operations, and let us say there is another chip that is 8089 which was used for connecting increasing more inputs and outputs in the system. So we connected all these three ICs to enhance the system performance. So, but the only disadvantage was you need a very complex circuit diagram, and you need very precise. You need a very complex. You need to draw. You need to understand very complex, because सिर्फ हो क्या रहा है, आप सिर्फ 8086 को 8087 या 8089 के साथ ऐसा नहीं है कि आपने तीन चिप लगा दी और तीनों को पैरेलली कनेक्ट कर दिया. It's not like that only. It's not that simple. It's that difficult कि आपको तीन प्रोसेसर्स को एक साथ सिंक्रोनाइज करना है, आपको बस शेयरिंग करनी है, because you cannot use separate buses. You need a common system bus for all the processors. That's why it is called a system bus. It is not a single bus which is dedicated to a processor. So you need a common system bus, and you need that if one processor is working, second processor is doing the other task, third processor is doing other tasks, that you need, you just want that how to synchronize all these things. So this was the basic concept of the networking, from where the idea of evolution of networking evolved. So anyhow, so we were discussing maximum mode. So maximum mode, I told you what is the purpose of maximum mode, and the last disadvantage was that it increases the cost of the system also. So maximum mode में जो dedicated pins थी, I told you these are from 24 to 31, and you need to extract out all these signals in the maximum mode. The purpose is this only. So first of all, we have started from RQ and GT0 and RQ and GT1. So I told you ये क्या है, ये है request and grant. ये किस लिए use हुए थे? ये use हुए थे to accept, मतलब अगर किसी processor ने if in a system he asked for the because we told we need a single system bus to be to share. So if any processor asks for the, let us say ki bus access, so it will create a request to the processor who is owing the bus and who is currently a bus master. So let us say processor A, B, C are there in the system. A is owing the bus, A is sending the data from the bus. So let us say processor B needs to have an access of the bus. So it will create a request. The processor which is owing, it will grant that request. So this is how these pins work. Request and grant. I told you three basic steps: request, grant, and release. So these were the three basic steps. Then I told you about this lock bar. Lock bar is something which because जब कोई other processor bus request के लिए दूसरे processor को request भेजता है, so it releases the bus at the end of the machine cycle. I told you the concept of T cycle, time, then machine cycle, and then instruction cycle. So you basically what you want that if any bus request is created by another processor, the processor which is the owner of the bus should complete the instruction, should complete the task which is assigned to that particular processor. So you use that prefix in front of that instruction. That prefix was lock. So you have used lock, and you have written you have written that instruction in the software part, and then finally if you have written that lock instruction in the software section, this 29th pin lock will be activated. So this will ensure that your processor will complete that particular instruction cycle. So I'm using the word instruction cycle. So next one, next thing we have discussed was S0, S1, and S2. So I told you these are the control signals. So these three pins are provided in every processor. So you have connected these pins together with a control signal generator IC, जिसका जो कंट्रोल सिग्नल जनरेटर आईसी था वो क्या था 8288. हमने वो क्यों यूज किया था कंट्रोल सिस्टम जनरेटर आईसी कि आप नहीं चाहते कि कोई भी प्रोसेसर कंट्रोल सिग्नल जनरेट करे, आप चाहते हो कि कंट्रोल सिग्नल सेपरेटली जनरेट हो और वो तीनों प्रोसेसर्स में से जिस भी प्रोसेसर को कंट्रोल सिग्नल को जनरेट मतलब कंट्रोल सिग्नल चाहिए तो वो रिक्वेस्ट क्रिएट करे, वो रिक्वेस्ट कंट्रोल सिग्नल जनरेटर ग्रांट करे और फिर फाइनली वो कंट्रोल लेटर से इनपुट पहले प्रोसेसर को भी इनपुट आउटपुट में रीड करना है, दूसरे प्रोसेसर को भी इनपुट आउटपुट में रीड करना है या राइट करना है. सो these are the types of the control system we have discussed ना, कंट्रोल सिग्नल सॉरी. तो ये इंडिपेंडेंट काम आप करना चाहते हो. अगर हर कोई प्रोसेसर कंट्रोल सिग्नल जनरेट करेगा तो इट विल बी अ वेरी टाइट सिचुएशन फॉर द सिस्टम कि किस कंट्रोल सिग्नल को वो कब सिंक्रोनाइज करे. So you have used a separate dedicated IC that was 8288 in the system for generating and handling all the control signals. So you have connected S0, S1, and S2 of each processor with that control system generating IC. Let me show you that diagram which we have discussed yesterday. So I told you this is not a complete diagram. It's just a reflection. You can also draw 8087 in parallel with this, the 8089 in parallel with this, and you can connect these three things with 8087 and 8089 and these three things. And you need to draw only one this 8288 and these three common S0, S1 and S2 signals तीनों processors के साथ आप इसमें डाल सकते हैं. And this again I told you कि it is handling all the control operations. तो क्लॉक भी यहीं से आपने इसको दी है 8288 को. एंड इट इज ये जितने भी इनपुट आउटपुट रीड मेमोरी राइट इवन योर AEN एड्रेस अनेबल जो आपका इसमें डिसेबल हो गया था 8086 में, तो वो सिग्नल भी आपका 8288 क्रिएट करेगा और जिस भी प्रोसेसर को बस एक्सेस चाहिए होगा. सो विल सी इन द टाइमिंग डायग्राम कि व्हाट इज द difference between the timing diagram of the minimum mode and the maximum mode. So this is how it is not decoding the these S0, S1 and S2 control signals. We have drawn a truth table yesterday. That जो truth table बना था वो कितने signal expect किए थे उसने 8 signals. So we have discussed all those 8 signals. And the last thing I think जो थी इसमें 8086 के पेन डायग्राम में, that was this QS0, QS1 and test bar signal. So test bar signal is also available in minimum mode. So maximum mode you have utilized this test bar signal QS1 and QS0 dedicatedly. So ये जो है ये तीनों dedicatedly दिए गए हैं प्रोसेसर 8086 में for connecting प्रोसेसर 8087. अदरवाइज इनका कोई रोल नहीं है. मैक्सिमम मोड में QS0, QS1 ये कल हमने डिस्कस नहीं किया था, तो आज जो है आज का जो लेक्चर है वो यहीं से शुरू कर रहा हूं मैं. So this QS0 and QS1 along with test bar, these are given in the system just to connect 8087. Otherwise these are of no use. बाकी सब जो है अदर प्रोसेसर लाइक 8089 भी कनेक्ट करने के काम आएंगे, लेकिन S1 and S0, QS1 and QS0 along with test bar is given in this 8086 processor in max mode for connecting 8087 IC. Okay, so I hope यहाँ तक clear है आपको, यहाँ तक कोई doubt? Is it okay? Anything yes, there in the chat box? Okay, fine. So let's move further. Just a quick recap summary. So R0, S1 and S2, it's S0 basically are the set at the beginning of the bus cycle 8288 bus controller will output a pulse as on the ALE will see. ये जो लाइन लिखी है हम टाइमिंग डायग्राम में देखेंगे कि कैसे होता है जो हम बात कर रहे हैं इन T2 ये भी हम बात करेंगे अभी that is memory read operation or input output read operation for an output AMWC and AI OWC is activated ये भी हम देखेंगे अभी टाइमिंग डायग्राम जब हम करेंगे the status bit of S0 to S2 remains active until T3 becomes the passive during T4. So all these lines, all these summaries for the timing diagram. If the reader input is not activated before T3, wait state will be inserted between T3 and T4. So let's directly jump to this timing diagram. So just give me a second. I'm just getting an important call. Just give me a second. So I'm coming back to you. So let's continue. I'm sorry and thank you for being there. Anyhow, so let us start with this timing diagram. As now, I hope now you are able to read the timing diagram because we have already discussed the timing diagram of the minimum mode. So the only difference is, as we have seen in 8086 minimum mode, सबसे पहले क्या होता है आपका your this ALE signal is generated. ALE, which is address latch enable. Now it is not there in 8086 maximum mode. So it is the address खत्म हुआ जैसे ही आपका address खत्म हुआ it is enabling that advanced signal. और जैसे और यहाँ पर आपका वो normal cycle जो चलता है so this is a normal cycle. So there are two more pins या two more signals which are given on this 8288 chip. I'll show you. It's not seen over here. Okay, anyhow, so there are two more pins in this 8288 chip, which are the advanced pins. So advanced read operation pins, advanced write operation pins in memory and in input output. So you can you have to show. I'm telling you, I'll provide you the exact diagram. So this is not a complete diagram I got from the internet. So I'll provide you the more correct diagram. More descriptive diagram rather. So in that diagram there are two more signals I told you. the signals are, that is advanced memory read, advanced memory write, and the second one is the advanced input output write. So advanced input output write, advanced memory write. Okay, so now moving further, उसके अलावा चार ये जो हैं वो तो रहेंगे ही रहेंगे, मेमोरी रीड, मेमोरी राइट, इनपुट आउटपुट रीड, इनपुट आउटपुट राइट. इसके अलावा दो और हैं एडवांस सिग्नल्स, वो दोनों राइट के लिए हैं. ओके, ये बात याद रखना. तो जब भी हम राइट ऑपरेशन की बात करेंगे तो विल शो देम. Okay, so as you can see, advanced memory write, advanced input output write. ठीक है, rest of the things are same. Clock pulse high, ALE enable हुआ clock pulse आते ही. So as I told you, there is a difference between ALE of the minimum mode and ALE of the maximum mode. ALE enable हुआ और इधर से आपका address fetch होना शुरू हो गया. जैसे ही आपका first T cycle आया, address fetch हुआ, पूरा address fetch हुआ, can show that particular address from A0. You can write from here, that is from A16 to A19 in this section. A16 to A19. And after the address, data is enabled when because data this DN is enabled. After that, this AL is disabled. Okay, now what you want to do that particular data, let us say you want to data transmit. So you have shown this high signal, so that data transmit means write operation. So you have activated that write operation. I hope ये clear है. Any doubts up till now? I'm not stopping this, I'm not finishing this topic because I know I just I have gone through a very quick timing diagram description because of the lack of the time. I'll again continue with this timing diagram description, more descriptive way in the next lecture with more descriptive diagrams. So any doubts up till now? यहाँ तक कुछ आपको part समझ आया? Please say yes or no. Please say yes or no in the chat box, or you can unmute your mic so that I got that idea कि आप
yes sir.
Okay, fine. So thank you. So please mark your attendance first, JMIT students, and please I request you do not